cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as possible. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Thanks. I'm Brendan Burns. I'm an engineer at Microsoft in Azure. I work on Kubernetes. I was also one of the co-creators of the Kubernetes open source project. And I'm excited to give a bit of an intro to those of you who may have heard of Kubernetes before, but haven't really had a chance to play around with it before. I want to sort of help you take your first steps into the world of Kubernetes. Some ideas about some prerequisites for expectations if you want to follow along with what we're doing at this time or at some other time. We're going to assume that you have Docker installed and that you've had some experience with Docker. So if you haven't built container images before, it might be the case that you want to come back to this recording after you've played around with Docker a little bit, but hopefully you've had some experience with containers and how to build container images. There's a lot of really great tutorials around on the Microsoft documentation as well as elsewhere on the internet. I'm also going to assume you have VS Code installed. You'd be with the majority of programmers if you did. There's also a really great Kubernetes extension for VS Code. If you haven't had that, if you don't have that installed into your VS Code, you can search for that in the extensions installer inside of VS Code and install that pretty quickly. And then I'm also going to assume if you want to play around at home, it's not necessary to go with the slides, of course, but if you want to sort of follow along at home, that you have a cluster provisioned. And it's quite easy, actually, to do this from inside of VS Code, and I'll show you how you can do that a little later on. All right, so I wanted to begin by talking about just a high-level introduction to Kubernetes. The idea behind Kubernetes really is that you can take a whole bunch of virtual machines, or physical machines, actually, if you're not in the cloud, and you can put a single API on top of them, and that API is more developer-oriented. It's more oriented around building applications rather than dealing with the details of machines or disks or networks and things like that. And so you can see here I've taken a couple of applications that I've put inside of containers, and I'm deploying them via the Kubernetes API. So what actually happens when you go and do that? Well, what happens is, just like when you double-click an application in an operating system and it finds a core on a processor to run, Kubernetes is going to go ahead and find a machine on which it can run that application container. So you've asked it to run these two different app containers. Kubernetes is going to identify a couple of different machines that are good places for it to run. And it's doing that scheduling based on a number of different things, but the most important thing that it's doing that scheduling based on is the resources required for the container to run. So every application is different, and every application is going to need different amounts of resources. And when I say resources, I primarily mean CPU and memory. Although, of course, if you're doing machine learning, it might include a GPU or other sorts of, more specific resources. And, of course, every application needs a different amount of resources, and this is kind of the first place where Kubernetes is different than thinking about virtual machines and traditional cloud infrastructure, because instead of asking for a virtual machine with a certain number of cores and a certain amount of memory to run your application, you actually attach that request to the application itself. And so you say, you know what? My application container, in this particular example, needs 1 core and 10 gigabytes of RAM. And this is the information then that the Kubernetes scheduler uses to find a place where it can run it on a particular machine. And in particular, what it's going to do is take a look at that request and say, hey, do I have a machine with that with those resources available? It's not going to overschedule. It's not going to place more containers onto machines than there are actual resources on those machines. And that's good, of course, because if your application needs a core to successfully handle user requests, you don't want it to be in competition with other containers for those resources. But of course, that also in some ways limits the amount of efficiency that you can obtain. So Kubernetes also introduces this idea of a limit. And when you think about a limit for resources, that's the maximum amount that the particular container can use. And that's defining the upper bound, if you will, not the amount that it needs, but the upper bound on the resources that it could possibly use. And when Kubernetes sees the limit, it actually is just limiting the resources you will use. It doesn't actually use those values in making a scheduling decision. Now what you see right here is that in fact the request is equal to the limit. And when you do that, that means that you will only ever use the resources that you're guaranteed to have. And this is sort of the safest place to be in Kubernetes, where the Kubernetes system itself will make sure that the resources that you need and that you might possibly use are available to you, and it won't have to it won't have to terminate your application if you run out of resources, because it's made sure that the limit that you can use is the same as the amount that you've requested. But of course, when people are estimating resources for an application, sometimes they do a bad job, or sometimes they set a value that is what is necessary at peak traffic, but it's later in the day and you're not receiving peak traffic for the day and you're using fewer resources. And so you want to potentially be able to take advantage of those resources, those sort of slack resources, in order to be more efficient in your usage of a particular machine. So to do that, you might do something like set the limit here to 2 cores and 20 gigabytes of RAM, whereas the request is 1 core and 10 gigabytes of RAM. When you do this, Kubernetes in the scheduler actually only guarantees that you have access to 1 core and 10 gigabytes of RAM. Any extra resources you use between the request and the limit are opportunistic. And in fact, if the machine, for example, runs out of memory when you are using more than the RAM that you requested, Kubernetes may actually terminate your application because it's run out of space for all of the applications on a particular machine. And so this is a more dangerous way to set up your application, but it also can be a much more efficient way to run a group of applications, because it enables them to sort of borrow resources from one another if they happen to not be using them. All right. And then the last way that you might set up resources is actually to request nothing and then set a limit. If you set it up this way with no request but only a limit, you're running what's known as best effort, which means effectively you're stealing resources, stealing idle resources from other containers that had requested them, but you'll be the first to be terminated if the machine runs out of resources. This is a great thing to do if you are running, for example, a background job, maybe testing or any other thing where you don't really care if it gets terminated, but you want to use as the minimum of resources possible. So those are sort of the 3 basic settings for resources for a container in Kubernetes. Request an equal to limit, where you're guaranteed to run no matter what. Setting a limit greater than the request, where you're usually guaranteed to run, but if you happen to use more than your requested resources, you may get terminated. Or best effort, where you don't actually request any resources, you only limit the number of resources available to you, and you'll be the first thing to be terminated if the machine runs out of resources. So let's actually take a look at this in practice. We're going to jump over and do a quick demo. And what I'm going to show you is a pod definition here that has no resources requested. So this is a simple pod. It's just going to run this Kubernetes Up and Running demo application, and it's requested no resources. Now this is actually a pretty dangerous thing to do. You don't really want to request no resources for 2 reasons. One, you may be killed if you don't request resources. Your container may be killed by Kubernetes. But also you can dramatically overschedule your machine. And in particular, in the Kubernetes extension for VS Code, we've actually added a linter that warns you that there are no resource limits specified, because we have found that oftentimes people don't specify resources, but they don't do it on purpose, and then they don't understand why their application misbehaves or gets terminated by Kubernetes when the machines run out of resources. And so we actually put a warning in there to help you. But if you do want to do that, it's obviously possible. And to take a look at how this works, we can actually try and schedule 10 of these pods that haven't requested any resources. So we're going to go ahead and create 10 of these pods. And you can see them being created right now. Sorry, 5 of them. I have my numbers wrong. 5 of these pods. And what we're going to see is if we list the pods that we're running, they're all in a running state. And so because we've requested no resources, Kubernetes has happily scheduled them out to the machines that are available to it. If they happen to use a lot of resources, those machines could run out of resources and your application could get terminated or run quite slowly because you've not told Kubernetes anything about the resources that it needs. So we'll tear that down and delete all of those pods. Now let's take a look at a different pod definition where I have actually specified some resources. So you can see here I've actually said I need 1 CPU and 100 megabytes of RAM. And I'm actually getting a little bit of a warning here because I've specified a number. The resources are actually specified as strings, so I'll convert that into a string to get rid of the warning. And now this pod can be scheduled. So let's go ahead and try scheduling 5 of those pods. So it's going to go ahead and have created 5 of those pods. But now if I actually get the pods, if I can spell kube control right, if you see I can get those pods, there's actually only 2 of those containers that are running, and the rest of them are in a state called pending. And if I actually describe one of those pending pods, what you'll see here is it says that the resources are unavailable. There's insufficient CPU to schedule those machines. And so because I've requested resources, I'm only able to run 2 of the pods because I don't have enough CPU in my cluster to run any more. That's good in the sense that the resources for those pods are protected. I know that we're not going to overwhelm them and they're not going to run out of the processor. But obviously if I really wanted 5 to run, by specifying resources, I've prevented 3 of them from running. And so you need to balance, the needs of an application to have a number of replicas with the needs to have an absolute hard guarantee to the resources that it needs. So we'll tear that back down and jump back over to the slides. All right. So now I want to talk a little bit, now that we've talked a little bit about resources for pods, I wanted to talk about health management for pods, because obviously scheduling things is great and making sure that everything has the right resources is great, but one of the other things that Kubernetes provides for you is the ability to automatically restart your application if it happens to fail. And this is very handy because, of course, applications crash at any particular time, and if it crashes and stays down, that obviously your users see a lot of problems. If Kubernetes automatically restarts your application for you, well, they might see a brief blip, but it's going to be much better. So let's take a look at this. Every container has a process that runs as the root process inside that container. It's process number 1, and that is the sort of the main process associated with whether or not the container is healthy or not. Okay, let's take a look at how this works. I've got here a simple Nginx pod, just like I had before, and in fact it's giving me the same warning about having no resources. And I'm going to create that container. So I'm applying it. And now what I'm actually going to do is I'm going to exec into that container, and I'm actually going to terminate process number 1, which is the root process in the container. And you can see there I'm running killed 1, which will terminate that process. And now let's get a look at the pods that are running. What you can see here is that I have a restart, and that container's only been up for 22 seconds. And so what's going on here is that when I terminated the process inside of the container, Kubernetes detected that the process had crashed and actually restarted the container for me. And in fact, it did it so quickly that you can't even see that it ever went through a not running state. This happens in milliseconds or less. And so my application is always kept up and running healthily for the end user. All right, so let's go back to the deck. But, you know, just keeping a process up and running isn't actually the best way to, it's a good way to start with health maintenance, but it's not the perfect way to go with health maintenance. And the reason for that is because you could have a process that's spinning and deadlocked that appears to be running correctly, but is in fact incapable of serving any user requests. Maybe you've run out of connections to a database or any other sort of thing. And so in addition to process health checking, Kubernetes has web-based health checking, where it consistently calls a web page on your application. And if that web page returns healthy, then, or at 200, then it assumes that the application is running correctly. And if that web page returns unhealthy, it's going to actually terminate the application as if the process had crashed. So this gives us the ability to actually inject our own logic that determines whether or not the application is healthy and not just rely on whether or not the process is running correctly. So let's take a demo of that. Here's another simple container application that I have. And what you can see here is I have a liveness probe defined. This is different than my other definition where I didn't have a liveness probe. This liveness probe actually gives the URL right here and the port that it needs to be connected for the health check. And so now we're going to go ahead and create that. All right, so that pod's been created. It's up and running. Now we're actually going to, what I'm going to do here is I'm actually going to create a connection to that pod, and I'm going to drop over to a web browser. Actually, I'll just go use it. Yeah, I'm going to drop over to a web browser. I'm going to go to localhost. And now I have this demo here, and if we go over to the liveness probe, what you're going to see here is a history of Kubernetes probing my application to see if it's healthy. So you can see it's returning 200 over and over and over and over again. It's probing every 3 seconds because that was the interval that I set for the probe. And what I can actually do right now is I can set my application to fail. And so it's now set to permanently fail. You can see it's receiving 500s. Are turning 500s, and in just a second, those 500s are going to go back to being nothing. And the reason is because Kubernetes actually just figured out that my application was returning 500s, it was unhealthy, and then Kubernetes restarted my application for me, and now I'm returning healthy 200s again. And I can do this again. I can say fail. And eventually, it's going to restart. And they'll do it again. One thing you might notice is that it actually took a number of 500s for it to fail, and that's because I've configured the number of failures in a row that you need to actually restart the application so that you don't restart for transient failures. So for example, I could say just fail the next one call. You can see it will return a 500 now, but now it's going to start returning 200s, and the application is in fact not restarted. And that's because Kubernetes needs a certain number of failures before it will actually cause a restart. All right, let's go back to the deck. The last concept with regards to health in Kubernetes is the notion of readiness. And what a readiness means is whether or not you're ready to serve. And in fact, what this means is not whether you should be terminated, but whether you should be added to a load balancer. Kubernetes has these service load balancers that we'll talk about in a second. If you put a health check at ready, and that returns false, then you won't be added to a load balancer. And this enables you to do things like initialize your application, download a large file, do whatever it is you need to do to get ready to serve, be healthy during that time period so you won't get restarted, but indicate to Kubernetes that you're not actually ready to serve data to end users. All right, so hopefully that gives you an idea about health inside of Kubernetes. I'm going to move on to thinking about how you put together your first deployment. Now hopefully you understand the details of how you specify both resources and health for an individual application. Let's talk about deploying a real application, a replicated application to Kubernetes. So what do? You've got the Kubernetes API, you've got a bunch of machines behind it. How do you get started? Well, one of the most important things is that the Kubernetes API itself is not your source of truth. Instead, you want to really think about the configuration files, those YAML files that I showed earlier, as being the source of truth for your application. And those source of truth should be in source control. If you're in source control, then you have all sorts of versioning. You have the ability to do rollback. You have the ability to do code review. You have all of the processes that we associate with software development associated with deploying your application to Kubernetes. So the absolute best practice is to ensure that all of your application data is maintained not in Kubernetes itself, but in source control in a Git repository. And in fact, you should never find yourself in a place where you are creating resources on the fly inside of the Kubernetes API. Always create them via code review, via Git push, merging to master, and then eventually moving on to doing automation so that you use something like Azure DevOps, so that you don't even take the contents of your Git repository and push them into the Kubernetes API yourself. There's an automation script, and it's easy to configure Azure DevOps to do this with the Azure Kubernetes Service, to take a Git repository and automatically apply all of the configurations in that Git repository to the Kubernetes cluster that you've deployed via the Azure Kubernetes Service. And then taking it a step further, you're going to want to actually think about how do you deploy to multiple regions, right? Because at this point, we've deployed our application to a single Kubernetes cluster. Maybe it's the development Kubernetes cluster, but of course, in any real application, you want to have a development cluster, a canary cluster, and a final production cluster, or maybe multiple final production clusters. And the final piece of that tooling then is to use something like Helm, which performs templating, so that you don't have a different copy of your configuration for every single environment that you're deploying to, but rather you have a single template that you can customize for particular environments, and Helm is a great tool for doing that. Helm will take a sort of parent template and customize it for each local environment. That allows you to keep consistent data in your original template while mixing in environment-specific stuff, and then again using Azure DevOps to deploy to, at first, a development environment, and then a canary environment, and if the canary testing works, finally to a production environment. So hopefully that gives you an idea about how to structure the configuration information that you have available to you in your in the configurations for your Kubernetes API. The next thing to think about is how are you going to actually design your application? Well, in Kubernetes, obviously, the application you're deploying is going to be a web server. Might be something like contoso.com. You're going to use DNS to associate that with a particular IP address. Those things are sort of outside of the scope of Kubernetes. But just below that, inside of your Kubernetes cluster that you deploy with the Azure Kubernetes Service, a Kubernetes service exists. That's a load balancer that's associated with that IP address. And then, of course, there's a pod. And in fact, there's going to be multiple pods that link together behind the service. And the way that this works is you use a deployment. A deployment is a Kubernetes object that knows how to replicate containers. And so you can use that deployment to give yourself multiple replicas of those containers. And because the service is a load balancer, it's going to actually distribute all of the requests to your application on that particular IP address out to all of the containers that have been created by the deployment. And in fact, coming up later on, a deployment can actually be also used to do a rollout from one version to the next. And that's pretty handy as well. All right, so let's take a quick look at what that looks like, what those objects look like. And here we go. So if we look over here, if I start with the service, this is a simple service that is the service definition for Kubernetes. It's saying, I want to serve on port 8080. Kubernetes has this idea of a selector. The selector identifies the pods that you want to load balance traffic to. And then I say I want a load balancer service. Load balancer service, as you can see here from the tooltip that the Kubernetes extension shows me, a load balancer service is one where a cloud-based load balancer is created, in this case an Azure load balancer, that gives it an external public IP address and allows traffic from the internet to come down to your service. To go along with the service, I have a deployment. And a deployment is a way of replicating a number of identical containers. And so you can see here I've got 3 replicas. I have some information about how I want to do a rollout, which means I want to do, saying effectively I want to do 25% rollout at a time. And then finally I have a template definition here, which looks very much like the pod definition you saw earlier. And this is sort of the blueprint, if you will, that is used to create each of those 3 replicas. So now that I'm here, I can go into that directory where my applications are, and I can actually, do kube control apply -f. And that's going to create the load balancer. And then I can do the same thing with the deployment. And what you can see here is already kube control get services. There's the load balancer that's being created. It doesn't have an external IP yet because it's going up into the cloud and provisioning that cloud load balancer, and it takes a little bit of time for that cloud load balancer to show up. It does have a cluster IP address, which is the local IP address inside of the Kubernetes cluster where you can access that service. And if I get the pods, what you'll see here is I have my 3 replicas, and they each have sort of random suffixes attached to them to make them individually shown, and they're all up and running. And so once that external IP address comes into existence, traffic to that IP address or through the DNS, through a host name to the DNS to that IP address, will be directed to those pods. I can actually scale this up and down, so I can actually go here and say, you know what, I want to scale this up to 5. And I can actually use the VS Code extension to say Kubernetes apply. It's actually going to show me a diff. It's going to say, hey, you know what? You're changing your replicas from 3 to 5. Do you want to do it? I'm going to say yes. And then what you'll see here, if I do the get pods again, is I now have 5 replicas up and running. So now I have, and 3 of them have been around for 80 seconds, and the other have been around for 6. So I've scaled up my application, perhaps in response to scale to more user traffic. And again, pointing to the fact that I'm using the source control as the source of truth, I didn't, use a Kubernetes command to scale my application. I changed the YAML file so that I maintain that record of what's going on. All right, let's go back to the presentation. So really, ultimately, if you're talking about reliability, you want to actually have your application be present in multiple regions, either because it's closer to your end users or because a region may have a power failure or something like that. And so in that world, you're going to use DNS. You're going to have multiple Kubernetes clusters. You're going to have those same service objects replicated for both clusters. You're going to get multiple different IP addresses and use DNS to load balance traffic between those places. Just like is shown here in this picture. All right, now I want to talk a little bit about how we keep our applications safe. This is just going to be a sketch, but how we keep our applications safe in an enterprise environment. Obviously, one of the great things about the Kubernetes API is that it allows multiple teams to use the same machines and the same API, but that you want to keep those teams separate. One of the first places you're going to turn is role-based access control, or RBAC. That enables a user who's using, deploying one application to manipulate their application's resources without touching the other user's application. So in this particular example, we're going to use access control to say, hey, you know what? Your team, and a namespace to say, hey, your team's namespace and the other team's namespace are separate. And we're actually going to put locks on those namespaces that mean that only I can access my team's namespace, only you can access your team's namespace, and that keeps us from accidentally deleting each other's applications, scaling them up or scaling them down at the wrong times. So the first thing you want to be doing when you're thinking about managing your cluster is that role-based access control. But of course, role-based access control isn't enough, because it doesn't do anything about what's going on inside the container. And for a lot of companies, we want to be able to ensure that, for example, you're using secure images, or you're not deploying software that hasn't been signed by a particular user. And so in order to do that, we've also have a notion of policy. Policy is available via Azure Policy, integrated with the Azure Kubernetes Service, and policy can be used to limit what you can express in the Kubernetes API. So via a combination of role-based access control and policy enforcement, you can really be sure that you can deploy enterprise compliant applications into the Azure Kubernetes Service. Obviously, that was a really quick sketch, and if you're interested in policy or RBAC and more about that, there's more advanced topics available in the Microsoft documentation as well as other places online. Hope that was a great quick notion of how you can get up and running with Kubernetes. Thank you so much for staying with us, and we will take your questions now.
We hope you enjoyed the webinar, and we will be sticking around for a few minutes for a Q&A session. We have some Microsoft experts on standby to answer your questions. To ask a question, simply type it into the chat window and we'll get to them as quickly as we can. You'll also find a resources widget in the bottom middle of your screen. In there, we've put additional links that you can use to supplement your learning. Lastly, we're always looking at how we can improve this experience for you. We'd